Example 12, last example 5.2, an observer notes that the angle of elevation from point A, some point away from the space shuttle, we don't know the distance we are from the space shuttle at point A, but let's say I'm the observer and that's as close as I'm allowed to get, okay? I can put a little pin in the ground or a flag in the ground and mark that as point A and know that there's some unknown distance, but I can measure the angle of elevation to the top. They have instruments to do that, okay? Then I can measure off a specific distance, in this case 17.5 meters further away, because I can get further away from the space shuttle, I probably can't get closer, and mark that off and determine the angle of elevation there. So this is all stuff that anybody could be able to figure out, okay? So you want to find out how tall something is, you have a limited access to it, you have the ability still to figure this out. We want to find out how high the space shuttle is. Now, the trick to this problem is that we don't know the initial distance away from the space shuttle. That matters. And we also, of course, don't know the height of the space shuttle. It's easier to find how far away we are than it is to find the height. And if we can find out how far away we are, it's very easy to find the height, because then it's just the opposite side. We know the adjacent side on a 27.2 degree angle, we can use tangent. So that's kind of the trick to this problem, is you want to find this, what they're not asking us to find, in order to find out what they are asking us to find. With that in mind, here's how it works. I've got two right triangles going on here. Let me show those. Let's see. This isn't going to work very well. Came close. Alright, there's one. Let's make it blue. Okay, we got that right triangle going on, right? And then we got the second right triangle. Alright, notice that V is a shared side on these two right triangles. We're on the blue right triangle, X is the bottom. On the red right triangle, X plus 17.5 is the bottom. So we've got two overlapping right triangles here, but they have some commonalities. If we take a look, first of all, at the 27.2 degree angle inside this, and we recognize that V is the opposite side, and X is the adjacent side. And of course, this would be the hypotenuse. But the hypotenuse isn't coming into play because we don't know anything about it. All right, based on SOHCAHTOA, tangent is opposite and adjacent. So I know that tangent of 27.2 degrees should equal the opposite side V over the adjacent side X. And a quick little cross multiply here. If I cross multiply, I'm going to get V is equal to X times tangent of 27.2 degrees. You can evaluate tangent 27.2 anytime you want to. I'm just going to leave it like that for right now. But just know that we're going to have to evaluate some stuff to be able to do this. We jump over to the red triangle. The angle 23.9 degrees down in this corner. We go across. This is also the opposite. But now X plus 17.5 is the adjacent. So same idea. Opposite and adjacent are the sides we're working with. The angle we have is 23.9 degrees, so tangent of 23.9 degrees is equal to opposite V over adjacent X plus 17.5. So here's where it gets to the point where I said it's easier to find X than it is to find V. All right. Tangent of 23.9 equals V over X plus 17.5. This tells me V is equal to X tangent of 27.2. So if I do a substitution, X tangent 27.2 replaces V in this structure, we get tangent of 23.9 degrees over 1 equals X tangent of 27.2 degrees over X plus 17.5. And just like that, we can now determine X by that equation, that proportion. We can cross multiply, do what we need to do there. If I can figure out what X equals, I stick X right there, multiply by tangent 27.2, that tells me what V equals. And that's how we're going to go about doing this. At this point, I'd probably evaluate tangent at 23.9 and tangent at 27.2. My board calculator's not on, so we'll just do that. Wait for a second while it opens. always do why it takes so long to open this thing. Almost there. There we go. Perfect. So, make sure I'm still in degrees. I am. And I'm going to type in tangent 23.9 degrees and tangent at 27.2 degrees. So we got 0.4431 for that, and we've got 0.5250 for this. So if I cross multiply this point, 0.5250x is equal to 0.4431x plus, and then 17.5 times.
Isn't it tangent 27.2?
It is 20. PJ, let's see, tangent 27.2. Let's go with 0.5139. Might help us get the right answer. 0.5139. 5139. All right, so 0.4431x and 0.4431 times 17.5 comes out to 7.7543. Just maintaining that idea about keeping everything rounded to 4 decimal places in my work. All I have to do to get x then is move 0.4431 over to the left and subtract. We're going to get 8070. 0.0708x is equal to 7.7543. So to get x, I'm going to take 7.7543 divided by 0.0708. And that comes out to 109.5240. 109.5240. And again, that's what x is. So if I go back to my picture, what I just determined was what x is. So this is 109.5240 would be from here to here. And my job is to find v, but again, v is simply x times tangent 27.2. So now if I take this and multiply it by 0.5139, so 109.5240 times 0.5139, that comes out to 56.28 meters. All right, every problem that you have in your homework, there's 3 of them. There's the independent practice. There will be a problem like this on your test or quiz. Will be like this. That's all the problems I had to choose from altogether. So you get 4 chances to practice this basically. On your independent, or on your test practice, or whatever your practice test, you get 1 more. Again, just they all work the same way. You're going to be getting these 2 angles in this measurement here. Find x first, and then once you find x, find v. There's always this substitution here that's easy to do. The other option would be to get x equals v over tangent of 27.2, put that there. That gets a bit ugly to look at. So you could find v immediately. It's a lot easier to find x and then just use that to find v. So I would recommend going that route.